All right, welcome back, guys. Now that we know what a transformation is, let's talk about our first specific type, which is our translation. Translation is also known as a slide. When we move along a vector, we're going to make a slide. Okay, now it's all going to go in the same direction. That's the direction of the vector. We'll talk about vectors later on. Now, a translation is an isometry. Isometry means that your image is congruent to your pre-image or your original. Okay, so let's take a look at these two different transformations and think about whether they're a translation or not. This one's a little tricky to look at, but like if let's say this is like a dog. There's the eyeball, little ear, and the snout. If I were to put the eye on this one, you could see that basically this has been reflected across a line. And you see how the eye is the same distance from the mirror? This one is actually a reflection. Each point on the image is the same distance from the mirror. Number two, however, if I take this one, I could slide it along a vector in this direction to correspond to that point. This point would slide along the same vector to that point, to this point. Now notice one thing here, all of the vectors are congruent. This one is a translation. Okay, to find the coordinates for an image of a figure in a translation, you're going to add to the x coordinates of the pre-image and add to the b coordinates of the y image. So let's take a look at what that means in reality. Translations can be written by an algebraic rule in this format where you've got this capital T, which means translation, and we're taking our x and y coordinates, we're going to transform them in such a way that we are going to add our x to our x values and to our y values according to the rule. So find the coordinates for the image of triangle ABC after the translation of x plus 2, y minus 1, and draw the image. So here are my coordinates of my original x and y's. This is my pre-image, also known as original. And all I'm going to do is I'm going to take my -4 plus 2, -2. -1 plus 2 is 1. -3 plus 2 is -1. 4 and a -1 is going to be 3. -1 plus 2 is 1. And -1 plus 1 is 0. Now when I draw the image, I have to be careful. So A prime, notice that I've got my prime notation with the apostrophe, is at -2, +1. That's A prime. It's very important to notate that. B prime is at -1, 3. B prime. And C is at 1, 0 for C prime. Without the prime notation, if I was just looking at these two figures on the coordinate plane, if it didn't have the prime notation, I would not know which one was the pre-image and which one was the image. You know, someone who wrote that movie, Transformers, knew about this because you had Optimus Prime after he transformed. Okay, let's do another one. This time we've got a quadrilateral. Here's our rule. We're going to have capital T for translation. We're going to take 2 away from every x, which is the same as left 2. And we'll add 4 to every y, which is the same as up 4. If this was minus 4, it would have been down 4. If this was plus 2, it would have been right 2. So here are my original coordinates. I've got my rule. And I'm just going to add these two numbers together. So I have a negative 1, 5. 1, 5, 1, 0, negative 1, 0. And then I would plot them on the coordinate plane and use my prime notation. Whew. It's a terrible one. But you get the idea. Okay? And it's easy to see, like if you start connecting vectors, all of your vectors would be in the same direction and they would be the same length. Okay? Now we're going to translate a triangle with the given vertices following this rule, capital T for translation, right 3, up 4. Now, it doesn't tell me that I need to write the prime coordinates, so I'm just going to take my original or my pre-image and I'm just going to count 1, 2, 3 to the right and 1, 2, 3, 4 up. And there's my F prime. 1, 2, 3 to the right, 1, 2, 3, 4 up. D prime. 1, 2, 3 to the right, 1, 2, 3, 4 up. And there's E prime. Okay, so this one we didn't have to write out the new coordinates, we just followed the rule on the coordinate plane. Okay, write the rule that maps the given pre-image to the image. Notice I can see that I've got my prime notation here. So I know that I am going from the blue to the red, which means I know I'm going right on the coordinate plane, which is x plus something, but I'm also going down. So this can be y minus something. So I'm just going to pick a point and I think, okay, to go from M to M prime, I go 1, 2, 3, 4 to the right, 2 down. So I'm thinking about plus 4 minus 2. I'm going to double check it. 1, 2, 3, 4 to the right, down 2, and I hit K prime. So I feel pretty confident about that rule. For number 2, notice we like to go, our eyes want to read from left to right, but this is where my prime notation is. So now I'm actually moving in this direction. So I'm going back left, so it's going to be x minus something, but I'm kind of moving up, so it'll be y plus something. I'm going to take B and I think 1, 2, 3, 4, 5 back, up 1. So it must be a minus 5 and a plus 1. I'm going to double check it. 1, 2, 3, 4, 5 back, up 1. There's my rule. Okay, and now without graphing, pretty easy still to do. We've got these as our original coordinates, and we're going to do a translation, capital T. I like for you to use that. That's the convention in our classroom. And now we're going to do x minus 4, y plus 4. The way I like to do these, kids, is I do all the x's first because I'm doing the same operation, and then I'll do all the y's. So I have a negative 4 minus 4 is a negative 8. A negative 2 minus 4 is a negative 6. 0 minus 4 is a negative 4. Now I'm ready to approach the y's. And with the y's I'm going to add 4. 1 plus 4, 5. 4 plus 4, 8. And 1 plus 4 is 5. And I have my prime coordinates. These are my original, these are my prime. For number 4, again, it's a translation. Why don't you pause the video, see if you can do this on your own, and come back and check your work. Okay, I'm going to do the x's first. Negative 4 plus 2 is -2. And -2 plus 2 is 0. And 0 plus 2 is 2. Now I'm going to work the y's. 1 minus 3 is a -2. 4 minus 3 is 1. And 1 minus 3 is a -2. And there you go, guys. You have completed translations without the coordinate plane using our proper notation. You have written a rule from the coordinate plane. You have completed a translation on the coordinate plane without writing your new coordinates. And here you have applied the rule, found your new coordinates, and graphed the image. So thank you so much. Let me know if you have any questions about translations, and I will see you in the next class. Have a great day. Bye now.